to the video lecture series on artificial neural network and fuzzy logic. In this video, we'll be discussing another numerical on artificial neural network. So the question is, obtain the output of the neuron Y for the network that is shown in the figure using the activation functions. The first activation function is binary sigmoidal and the second activation function is bipolar sigmoidal. So let us look at the architecture first. In the architecture, we can see we have three input neurons, X1, X2 and X3, and we have an output neuron Y. The connecting weights are 0.1, 0.3 and minus 0.2. Now in this architecture there is one minute difference from the previous one, that is here we have a bias now. So we have a bias. Bias has always an input of 1, that is 1.0. The weight for the bias is 0.35. So bias also gets added to the output neuron. So now we are being asked to obtain the output of this neuron Y. In any output neuron, there are two functions that happen. So the first function is the summation of all the inputs, that is x1 w1, x2 w2 and x3 w3. And in the second part, we apply the activation functions. So the activation functions that been asked is binary sigmoidal and bipolar sigmoidal. So let us see how to solve this numerical. We have input given as x1, x2 and x3. We have weights w1, w2 and w3 and bias as 0.35. Input to the bias always remains 1. So the net input to the output neuron is given by using this formula. Y in is equal to bias plus xi. I is ranging from 1 to n. N here is 3. So we have, since 3 input neurons, the value of my n is going to be 3. Y in, if I expand this equation, the summation, Y in becomes bias B plus I'll be substituting the values from 1 to 3. So we have x1 w1, x2 w2 and x3 w3. All the values are available with me, bias as well as input x and the weights w. I'll substitute the value and the value of input to the output neuron yi or y in is 0.53. So the numerical is not solved completely. I have been asked to obtain the output of the neuron Y. So output means a value that is your output of the neuron. I want to find the value. Till now what we have calculated, the values that is input to the output neuron. So the second part we have completed with the first part, that is the summation. Second part is the activation function. So first we'll be considering the binary sigmoidal activation function. So let us look at the formula of the binary sigmoidal activation function. For binary sigmoidal activation, Y, my output, is going to be the function of the input that we have just calculated. Formula for binary sigmoidal is 1 upon 1 plus e raised to minus y in. Y in we just calculated, it is 0.53. So we'll substitute the value 1 upon 1 plus e raised to minus 0.53. You can solve this using your calculators and the final output comes to 0.625. Similarly, for bipolar sigmoidal, the values that we'll calculate, the formula changes a little bit. Y is equal to f of y in, and the formula here is 2 upon 1 plus e raised to minus y in minus 1. I substituted the value of y in, which is 0.53, and the final value that I get is 0.259. So these are two values for two different sigmoidal functions, activation functions. Always remember, output neuron has got two functions. The first is we calculate all the inputs that are coming towards the neuron using this formula. Y in is equal to b plus summation xi wi. Once the input neuron is calculated, the input of the neuron is calculated, the second thing that we calculate is the activation functions. Since we have two different activation functions, formula for both the activation functions are available with us. We put the value of input that we just calculated and get the final value, that is the output of the neuron. So thank you for watching this video. I'll come up with the next numerical in the next video. Thank you.